So yeah, let me check the good afternoon, no, and let me check the participant. Okay, Cardinal. I'm sorry about last meeting, no. Just not available to do things. Anyway, no, you must have received my message. 1, 2, 3, 4, 5, 6. So 7 na lahat. Okay. So we have Arellano, Atiensar. We have Mation, Dabon, De Jesus, and Hardinel. Si Hardinel pala. Hindi si Villar-Luares. Okay. So good afternoon, everyone. So I haven't checked your your answers yet, but we are ready to discuss them. So very self-explanatory naman. I have prepared an Excel worksheet. No, I haven't written the answers yet, but I have prepared it for us to start solving the problem. This is page 109. Okay. So ganito yan. Can you see the Can you see the worksheet, everyone? Klaro ba? Hindi ko malagyan ng arrow ito, no? Hindi ko ito malagyan ng arrow. Okay? So, do you know how to place an arrow? Ayaw maglagay ng sa Excel. Sinubukan ko na yung ibang lines niya, ayaw. So, dapat may arrow dito. Okay? And then ito yung problem. In the case of a 12-bit address identifier, in particular with an IO device, show the program execution of the following, no? And then we are given that there's a load AC from IO. So load IO, no? So the instruction code or the operand, the opcode is 011. 011 is 4. Do you follow? Mali pala itong aking no? No, 3 pala, 3. So 3 pala ito. I'm sorry, no? It should be 3. 011 is 3005. Okay. Kaya ko na lang, no? 011 is 3. So the opcode, remember 2 is load. And 5 is store. Okay. No, and ano nga yung store? 3 yata, no, 5 kasi is add. Do you follow? So halos pareho lang naman siya, no? Instead of load 5, we say load IO5, which means there's a device number called 5. A device number called 6. No, so dalawa. Now, devices in a way, no, are addressed also numerically, no? You follow? May numeric port address. Ang tawag dyan, port address. We will just discuss that in a later number, no? Kasi may question rin dyan, no? So now instead of just memory, we have devices. We have 940, memory 940, and 941. We assume this is 3. We assume this is 5. You can assume any number. Okay? So load is 11, and then store is 111. Store IO, no? We follow. Add is still 5, no? We have that in our nandito siya sa let me look at that, no? Wala dito, no? Dami na kasing ka-open, no? Okay, sandali, open ko na lang. Page 109. Andito na pala, page 109. Ito yun, no? So, page 109. So remember, add is 101, that's 5, no? And then 10, which is store, and 01. This time we have load AC from IO, not from memory. Okay. We also have store AC to IO device. So which means that this may be separate I/O devices, no? Maybe one is a keyboard and the other is a printer. Okay. First, we load AC from device 5, and then we add the contents of memory location 940, and then we store the result to device 6. Okay. So ganito yung memory natin. So instead of this, we have 3005 because load is 11. And then 5940 pa rin because that's add. And we have 70006. So these are our devices. This device 5, this is device 6. This memory 940 and memory 941. We have 3 instructions. No? So each instruction will have an execution phase, a fetch phase, and execution phase. Do you follow? Any questions? That's 3.1. So iti-trace natin ito. Una, the PC is pointing to 300. You can use any other address, no? Ginawaya ko lang yung sa ano. So, una naka-point siya sa 300, which is this address. Okay? So, it will load the IR from the memory. So, magiging 3005. I'm sorry. Okay, this will become 3005. Okay? Do you follow? Okay? This is the execute. This is now the fetch phase of the load IO5. Okay, so tapos na yung fetch. And then pagkatapos, yung execution niya. Okay, now PC will become 301 and AC will become 5. Okay, so whatever it is, that because device 5 has contained, gawin na lang natin itong 4, no? Gawin natin itong 4. No? So this will become 7. Do you follow? So AC will become 4. Okay, do you follow? Because what is loaded into the accumulator is the address from device. Rather is the content of device 5. So nandito na siya ngayon after the execution of load IO5. Pagkatapos, we are going to add the value 4 to the value from memory, particularly in address 940. So we have 5940. Okay, so there will be 2 phases, no? A fetch phase and an execution phase likewise. So in the fetch phase, we will have the same process. What is in memory is transferred to the IR. During the execution phase, no? 5940 means add. Okay, 3 ito, no? 3 plus 4, this becomes 7. The accumulator becomes 7. Okay, and then the PC becomes 302 because it increments by 1. Okay, okay. Ito mali ito, sorry. This is the 3005 and this is the 3. This becomes 3. Okay, you follow? During the third, we'll store the result of which is 7, no, to IO6. So what will happen? First, of course, there's a load, no? There's a load of the instruction which is stored. So 7006 is transferred to the IR. Okay, and during the next phase, at the same time, no, the value 3 is added. No, sorry, hindi pa pala, 4 pa ito, no? The value 3 is added to the accumulator which is 4, so this becomes 7 at the second phase. And then we have 7006, which we load, okay, store the value 7. 7, accidentally 7 din yung ano, no? Please don't be confused, no? 7 din yung value, but the opcode of store is 7 because it's 111. Tatlong 1, no? Do you follow? This is, ang opcode nito is 3, while the opcode of this is 7. So any questions, no? Do you follow? So pareho lang, no? Okay. Now, the next question is a little more complex. Ang sabi dito, any questions so far? Can we proceed, no, to the next? The program execution of 3.5 is described in text using the 6 steps. Expand this description to show the use of the MAR and the MBR. No? So sinabi ko na ito, in-explain ko na ito, no? Before. So this is the program. So anyway, we have it here in our Excel worksheet. Nandito yung 3.2. Ito yan. No? So we will expand this further. No? What happens, we will include the MAR and MBR. Okay. So dito include natin ang MAR at saka MBR. Okay. Nag-copy, no? I hope it's clear, no? Anyway, expand ko na lang. Copy. Bakit ayaw mo copy? Dali lang. Who's coming? Espera. Espera is here. Bakit ayaw? I'm sorry, no? Hindi ko makukuha. So we are now in 3.2, no? We are going to use figure 3.5, but involve MAR and MBR. Okay? Okay. So what are the two subphases, no? Memory phase and increment phase. Okay? Anong tawag doon sa ating ano? It's in our Dagler site, no? Okay. Actually, may answer na dito, no? Okay. Address phase. MAR receives PC. Okay. And then the last is the memory phase. Okay. Number 2 ito, no? First, the address phase. MAR receives PC. Okay. So 300. Ang MAR becomes no, MAR receives address of the IR. I'm sorry, mali yung ano. MAR receives, no? This is the address phase. Address of the IR ito. So let me edit this, no? The address phase of the IR, okay? Kasi hindi pala ito execution, no? The IR, no? Hindi, kasi what's a MAR receives, ito yung ano, MAR receives IR, the address phase. Okay? M of IR. It's called the address phase, which means that the address is being fetched from the instruction register. You follow? So let's look at that. No? Ang pinakauna kasi, ang IR will get 941. 940, no? 940. Okay, that's the first step. IR receives Kasi pag fetch nito, makuha ito ng IR. 1940. Diba? Okay? Now, the MAR, okay, will get the address part of the IR. So this becomes 940. Okay? And PC receives PC plus 1. Okay? So this is 301. Okay? Okay? And MBR, ang mangyayari dito, okay? MBR will get the value of, when you say load, okay? MBR will get the value of 3, okay? Before it is added to, ano? Kasi the load, we load the MBR before it's added to 3, no? So the IR is 1940 here, and the MAR is 940. Dito, wala pang value ang MBR kasi the load has not been executed yet. Okay? So wala pang value ang MBR. So take note, no? When the value is fetched, it is fetched at the MBR first, and then AC receives the MBR. Okay, during the execution. Do you follow? Do you follow? Pinakita ko yun doon sa face, no? Okay? Do you follow? Now we now have here as 301, and the PC becomes, the IR becomes 5941. Okay? Kasi ito, kukopyahin ito dito, no? Kung saan naka-point, wherever the PC is pointing. Okay? Right away, the MAR will have 941. Do you follow? Do you follow? And the MBR, which is dito, no? By the way, 941 pa rin. This will now become 302. That ends it, no? Tapos na, nandiyan na yung 941. Wala ang MBR, the MBR previously is 3. You follow from the previous step. Okay? Pag execute itong 5941, okay, when 5941 is executed, MBR becomes the contents of 941, which is 2. Maging 2 ito. Do you follow? Do you follow? And this is 941. And the PC becomes 302 because it's incremented by 1. This is still 5941. What happens to AC? AC here is already 3, no? Do you follow? 3 na siya dito. What happens is, ano ba yung ating, 2 pala yung MBR, no? 3 pa rin, okay? But, during the add, no? MBR becomes 2 and it's added to the previous value of AC. So 2 plus 3 magiging 5 ito. Do you follow? Do you get my point? No? So we are including here the address phase and the memory phase. Okay, the address phase is when the address in the IR is copied into the MAR. Okay? The memory phase is when the actual, okay, execution, rather the actual contents, no, is copied into the AC. Okay? Do you follow? So dito, what's the AC here? It's 5. It's previously 5, no? And then the IR now is 2941. Okay, because it points to the current, ano, which is 302. So 2941 ito. So this becomes 941 again, no? 941. Okay. The MBR is previously 2. Do you follow? So 2941 ito pagdating dito. Okay. Now the PC becomes 303. The accumulator is 5. Okay. The IR is still 2941 because it doesn't it's not included anymore. No? Okay. And that the MAR is 941, is still 941. Okay. And okay, the MBR, no, is 5, no? 5. No, it's still 2 because it was not changed, but this will now become 5. Okay. Do you follow? Do you get my point? So that's the answer for 3.2, where we have involved MAR and the MBR. Now, in other books, it's called the address phase and the memory phase. The memory phase is when the data is copied into the MBR. Do you follow? No? Memory phase. Ang address phase is when the address of the IR is copied into the MAR. Let's look at that. Tama ba yung aking ano? No? Oh, ito yun. No. Mali ito no? I'll check the memory phase, no? Dapat hindi siya, kasi nasa IR na siya no? MBR receives, no? M of MAR, okay? Kasi i-read siya no? Let's edit this. MBR dito dapat. So, kopyahin ko ito, no? Kasi it is the same for all. Isa lang naman pala. No? Let's look at our answer. Involved pala ang MBR dito. Okay? Kasi MBR receives memory as addressed by so ang MBR dito na magiging 3. That's why involved dito na siya naging 3. Kasi MBR receives 194T. Okay? Kasi bago siya anong tawag doon? MBR receives M addressed by MAR. Okay? Okay lang naman kasi dito mag-change naman siya, no? Okay? Kasi i-fetch siya eh. Do you follow? Okay? It doesn't matter because it will change anyway, no? 5941. Kasi i-read siya galing sa memory. So, the MBR will really change. No? This is 2941. Okay? Everything that is read from memory will go through the MBR. Do you follow? Sa execution phase, it doesn't matter if it has changed. No? Anyway, no? So, any questions so far? Now, we'll go to 3.3. So, maganda itong 3.3. No? Okay. Consider a hypothetical 32-bit microprocessor having a 32-bit instructions composed of 2 fields. So, ganun talaga yung instructions, no? You have an opcode and an operand, okay? Okay, the 32-bit instructions composed of 2 fields, no? The first byte, so which means that 1 byte is the opcode. So, the remaining will be 32 minus 8, 24 operand. Do you follow? Do you follow? 3.3. Okay, do that, no? So 3.3, okay, and just can I just expand this? So we have 32-bit instructions, right? How many of ang opcode? Opcode is 8 operand is 24. Why is that? Because 24 plus 8 is 32. Okay? Any questions so far? So letter A. Anong unang question? Okay. What is the maximum addressable bytes in memory? Anybody? Anyone? Quickly. A. Maximum address. The biggest memory you can install. In Windows, in 16-bit, magkano ang pinakamalaki niyan sa Windows? Villar Luares. So, sinong marunong nito? How much is the addressable memory? 2 to the 24, no? No? Equals 2 raised to the 24, no? Simple math, no? Okay, ano natin yan?
Last person and see if they win this shit, and they will.
Okay. Format natin. So ito, no? This is the answer, okay? 167, ang laki, no? 16 MB. Okay, you follow? Almost 17 MB. Okay. Letter B. Discuss the impact of a system speed if the microprocessor has a 32-bit local address bus and a 16-bit data bus. Okay. So, kung 32-bit ito, no? The IR is 24 bits. Is 32 bits. But the MAR is 24 bits. And the MBR is hindi naman sinabi kung gaano kalaki. 32 bits, 32 bits yan lahat. Okay? We will assume. Okay? So, if you have a 32-bit local address bus, okay, the whole address, which is only 24 bits, can be placed. Okay? Can be placed on, can be read once. No? Do you follow? Data is read once directly. Why? Kasi we have a 32-bit address bus and we are only using 24. Do you follow? Do you follow? Okay. Only part of the address bus, no? Not all of the 32-bit address bus will be used. Why? Because we only have how many? We only use 24-bit addresses. Di follow? So okay lang yan. Because sobra siya. Okay lang yung sobra. Ang problema yung kulang. Okay? Kung 16-bit data bus, 16-bit data bus means 2 bytes can be read at a time. Diba? Do you follow? 2 bytes in memory. Okay, 2 to the 16 nga, no? 2 to the 2. Sino nagsabi 2 to the 16? 2 to the 24 lang, no? Kasi 8 minus 32. 2 bytes can be read at a time. It will enhance the execution of the memory read because instead of just reading once, we can read 2 bytes at a time. That's the impact. Do you follow? B.2. 16-bit local address bus. Anong problema nito? We cannot install a maximum memory because 2 to the 16 can only, that's your right, can only accommodate how much? How much can your, 16-bit Isulat nga natin equals 2 raised to the 16. 64 MB ito eh. Okay? 65536 lang. Okay? A 16-bit. Local address bus will not allow full use of memory. I-follow, di ba? Okay? Hindi mo magamit yung buong memory because you only have 16-bit and you have 24-bit addresses. So, 65536 lang yung install, no? 3.3 pala tayo, no? 16-bit local address bus. So, ganun. Okay lang yung, there's no problem with data, no? How many bits are needed by the program counter and the instruction register? How many bits? Kung gaano kalaki yung addresses. Di ba? Di ba? Kung gaano kalaki yung addresses, how long is the address? 24 bits. Okay? Do you follow? C. The PC and IR should be 24 bits each. At least. To be able to accommodate address. Accommodate all memory addresses. Do you follow? Do you get my point? I-upload ko ito, no? 3.4. Any questions so far? Itong 3.4 tsaka 3.5, challenging ito eh. Can somebody explain this to me? Consider a hypothetical microprocessor generating 16-bit addresses. Okay, so 16-bit addresses yung program counter, 16-bit addresses din yung instruction register. Of course, the memory address register is also 16 bits. Okay? And assume are 16 bits wide. All the program counter and the address registers, MAR, no, and IR, these are the address register, also 16 bits wide, and having a 16-bit data bus. What is the maximum memory? 65536. Okay. Isulat ko na lang, no? Dumating, kadali lang. Isulat ko yung problem para mas maintindihan. Okay? Who's in here? So, meron bang coming? Wala na, no? I didn't see anyone coming. Okay, letter A. Equals to raised to the 16. Lang na butang. So this is 64K. Ilang ako sa. Okay, letter A. Letter B. What is the maximum memory address space that the processor can access directly if it is connected to 8-bit memory? So 2 to the 8, 2 to the 18. Instead of 16, we'll have 8. So 256 lang. 256 lang na memory. That's only 1/4K. Okay. You follow? It's letter B. Letter C. What architectural features will allow this microprocessor to access a separate I/O space? Now, can anybody answer this? Answer this for me. Kasi may ano ito eh, doon sa dalawang klaseng ano. If an input-output instruction can specify 8-bit input-output port. Unahin na lang natin ito. Okay? How many 8-bit I/O ports can the microprocessor support? Okay. T.1. T.1, how many 8-bit? 256 ports. Okay, kasi 8-bit nga eh. D.2, this is 64K ports. Okay? I-follow. Ito ngayon ang letter C. What architectural features will allow this microprocessor to separate and to access a separate I/O space? Anyone can somebody explain this to me? Kasi nowadays there are two ways to address I/O. There's what is called memory mapped I/O and I/O port addressed I/O. Okay? Do you follow? Memory map I/O and port address I/O. The one we are solving here in 3.1 is port address. May address yung mga ports. The IBM PC is port address, no? The Mac OS ordinarily in its original form was memory mapped. Okay? So ganito yan, no? In memory mapped I/O, we do not distinguish addresses whether they are memory or I/O. Ito yun. So for example, addresses 0 to 940. 64K. So say 16 MB. Pagpalagay natin 1K. Ito yung memory natin. Okay, 1K up. For example, ito yung 000, 1, 2, 3. Dito yung 1,000, okay? Ito yung memory map. Okay, for example, this is device 1, keyboard. Device 2, printer, a mouse. Device 3, printer, and so on and so forth. No? Device 4, hard disk muna. Okay, device 4, printer. Okay, itong 1001 pataas, actual memory ito. This is now actual. Follow? Ang ibig sabihin, what it means is that in memory mapped I/O, whatever you place in this memory addresses will also put to the I/O device. So for example, if you load this with a value 5, it will go to the keyboard. If you read the value of memory address 0, it will read the keyboard. If you read the address of memory address 1, it will read the mouse. If you load an address, or rather a value to address 2, it will go to the hard disk. If you load, rather you store a value to the memory address 3, it will go to the printer. Okay? So there's a mapping between memory addresses to actual device. Okay? So, ang ano lang dito, problema dito, what's the problem with this? Magagamit mo yung memory. You follow? And there's part of memory that is not used. And there's a problem here when devices have different speeds. Because memory has uniform speed, but I/O has different speed. Diba? So, kailangan may synchronization between memory and I/O. Kasi, mas mabilis yung hard disk kaysa keyboard. Mas mabilis yung keyboard kaysa printer or whatever. Diba? Diba? Do you follow? So in port address IO, there are two sets of memory addresses. You have memory address and port addresses. Do you follow? So there are dalawang sets of addresses. So like in this example, no, we have device ID number 5, which is a port address. We have device ID number 6, which is a port address. We have 940, which is a memory address, and 941, which is memory address. It may happen that there's also memory address number 5. Do you follow? Do you get my point? What's the disadvantage with port addressed IO? Anyone? Because the disadvantage here is you will have separate instructions for port, for IO, and memory. Okay? So, programming is more complicated kasi mas marami kang commands. You'll have more commands. Okay? Unlike in memory mapped IO, the same command will be used to load and store from memory or from input device. Pareho lang silang load. Magkaiba lang kung ang depende lang sa address. Now, in this example here, no? The example in 3.1 is port address. We have a load IO5 and we have a store IO5. So we have two load instructions. We have one for load memory and we have another one for load IO. Okay, para i-distinguish yung port addresses from memory addresses. Unlike if this were memory map, isa lang dapat yung load. Depende lang sa address na ilalagay. If the address is mapped to a port, then it goes to IO. Do you follow? Okay? Okay? Do you get my point? Okay? Any questions? No? I hope you distinguish, no, between memory mapped IO and port addressed IO. Yung example 3.1 is a port address IO. So that's letter C. No? Nilagay ko na lang yung letter C dito. No? Yun ang main difference. So one way to be able to have to have a separate address space is to use port addresses. No? Now the problem with that port addresses is you will also have to use separate instructions. Okay? Unlike kung memory map IO, isa lang yung instruction. There are advantages and disadvantages. Nothing's perfect here, no? So 3.5, ito ngayon yung ito yung intriguing question. Did somebody answer this? Huh? Pwede ka na, if you have answered this, you can start working at Intel or in Asus Tech. Okay. Consider a 32-bit microprocessor with a 16-bit external data bus. So, meron siyang galing sa processor papunta sa memory, meron 16-bit. Driven by an 8 MHz input clock. What do we mean by 8 MHz input clock? Anyone? Ibig sabihin ng 8 MHz input clock.
Per 1 second, sir.
8 million instructions ang kaya niyang i-process in 1 second. Do you follow? So, gaano kabilis yung 12 GHz? So, it means 12 billion instructions ang kaya niyang i-process in 1 second. Do you follow? Huh? Okay. What is the impact of that in our design? Kasi ganito yan. If you look at balik tayo dito. Doon sa dito sa balik tayo dito sa ating micro instructions, no? Sa fetch and execute. Okay? Kasi isang ganito, one of this is one micro instruction. one of this is another micro instruction, this is another micro instruction. So for example, for the execution of load, you will need 5 micro instructions. Do you follow? Depending on the instruction, it will consume clock cycles. So 5 clock cycles ang gagamitin ng load. Ang add naman will have 3 executions for the fetch and 3 cycles for the execution. So add will have 6. So mas mabagal yung add kaysa load. Do you follow? Bakit mas mabagal yung add? Kasi 6. Kung sa command sa program pa 6 commands. Okay? Okay, sa store only 5. Okay? Ang ibig sabihin ng 8 megahertz is it can execute 8 million of this in 1 second. Do you follow? So isang ganyan, 8 million ang makaprocess niya. Do you follow? Okay? Any questions? Isang to si Atyansar. Atyansar, did you follow?
Yes, sir.
So, basta isang ganito, isang micro instruction ito. Pag 8 megahertz, 8 million ka muna na yung ma-process in just 1 second. Okay? Do you follow? So the question is, assume that this microprocessor has a bus cycle whose minimum duration equals 4 input cycles. Ibig sabihin, mabagal yung kanyang ano? Ibig sabihin, mabagal yung kanyang bus. What is the bus? The bus is the circuit that connects the processor to the memory. Okay? 8 micro instructions nga yung ma-process niya. Pero yung bus can only how many deliver? It will use 4 input cycles man. So it's 4 times slower. Do you follow? Do you follow? 4 times slower yung ating bus. Kasi sa kanya isang read niya, it will take 4 memory cycles. Ibig sabihin 4 na instructions na yung natapos ng processor. Yung bus isang data pa lang. Do you follow? So we can say that the data bus has a clock cycle of 8 divided by 4, 2 megahertz. Do you follow? So 2 bytes lang, 2 million bytes lang ang makuha niya every second. Habang yung ano is 2 million. Do you follow? Do you get my point? So mabagal yung ating bus 4 times. Kasi 4 cycles nga yung gagamitin niya sa clock. Okay? So if the frequency of our bus is 8 megahertz, or rather our processor 8 is 8 megahertz, yung ating data bus is only 2 megahertz. Do you follow? Kasi in 1 second, 8 million yung matapos ng processor, di ba? Kaya lang, yung data bus will occupy 4 bago niya 4 cycles bago siya maka-read or write, bago siya maka-transfer. So ibig sabihin 2 megahertz lang yung speed ng ating data bus. Do you follow? Now, what is the maximum data transfer rate across the bus? That is in bytes. So ano man 2 megabits man. So 2 million divided by 2. Divided by 8. Okay? So that's that in terms of the number of bytes. Kasi ang bits niya is 1 bit is 1 megahertz. Okay? 3.5. AA. Ang data bus ay microprocessor is 8 megahertz. The data bus is 2 megahertz. Ibig sabihin, 2 bits. Okay. In 1 second, what is the data transfer rate? In bytes. So yung 2 million, i-divide natin by 8 because we know that 1 byte is 8 bits. Okay? So 2 million. 2. 1, 2, 3. 1, 2, 3. 2 million na lang. Total, wala naman tayo magawa doon. Di ba? Divided by 8. So this is what? 250K. 250K. B. Bytes, no? Bytes per second. Okay, that's the data transfer rate of the data bus. 250K bytes per second. Kasi 2 million yung ano, divided by 4. Okay. 2 megahertz, no? Divided by 8. 2 megahertz, 1 megahertz is 1 bit. Okay? That's 3.58. Now, which is better? Ito ngayon. Which is better? To increase the performance? Is it better to increase the performance of the external data bus? Is it to increase its performance? Would it be better to make its external data bus 32 bits? Kasi 16 bit lang siya ngayon eh. Diba? Which one is better? Increase double the size of the bus or double the size of the frequency of the bus? Asan ang mas maganda? Gawin natin siyang 32 bits. Palakihin natin, di ba? So it can double. Kung baga parang highway. Instead of a 2-lane highway, gagawin natin siyang 4 lanes para it can read 4 bytes instead of 2 bytes at a time. Do you follow? Sandali lang, no? Dalawa pala yung ano, no? Times 2 pa pala kasi dalawa yung mabasa ng ano. Times 2 pa pala tayo. Dalawa pala yung mabasa ng ano. Dalawa pala yung mabasa ng ating memory basa. I'm sorry, no? Hindi ko na-consider, no? Times 2. Kasi 16 bits pala yung ating data bytes. 50. So 500K bytes. Akala ko 1 byte lang, no? 5K bytes per second. Okay? Yun yung data transfer rate niya. Okay? We follow? Now, the question is, which one is better? Gawin nating 32 bits instead of 16 bits or gawin nating 4 megahertz instead of 2 megahertz? Anyone? Math ito eh, no? Math. Pag-write tayo sa math. Pero actually, simple algebra lang ito eh, no? Do you follow? Okay. If we will double the bus, what will be the data transfer rate? Instead of 500K, magiging paano yung times 2? Kasi madoble na ngayon. Instead of 2 bytes, madoble na, di ba? Right? Double the bus you will have. Kay madoble man. Kay instead na 2 bytes, 4 bytes naman. Okay? So pila na ni? 1 megabyte. Ang kanyang data transfer rate is 1 MB per second. Ay, 1 MB na. Ay magbilis man. Diba? Madoble man ay ang gina-read at the time. Any questions so far? Diba? Kasi from from 16 bits himuna tong 32 bits, so madoble yang mabasa every now and then, no? 2. Double the clock. So magiging 4 megahertz clock. Diba? 4 megahertz, right? Okay. So this is, how much is 4 megahertz? 4 million. 4. 1, 2, 3, 1, 2, 3. Okay. Do you follow? Tapos, 2 bytes at a time. It's slower. No. I-times 2 natin siya. Mas mabilis na siya ngayon ang clock. Kasi ang clock ang pinabilis natin eh, no? Because there are 16 bits. Okay? Times 2 lang, di ba? Hindi times 4. Yung kanina, times 4 yung kanina kasi naging equals this times 4. Okay? Ano tawag dito? Bits. Per second. Ito bytes per second. Pag double the bus, 1 MB atong data transfer rate because it will just matter on the ano. No. Now, 4 siya. Ngayon, this will not be times 4, but this will be times 2. Okay? Do you follow? Now, divide natin yan by 8. Divide by, no, that's now, how much? 8 million, right? 8. Tama ba tayo? Times 2 ito kasi 2 bytes ito. Times 2 pa rin siya. Pero 4 megahertz na. Okay? Ilan nag-0? 6 zeros. This is 8. Okay. Ano ba? Kasi pag i-double natin ang bus, this is 500 kilobytes. So magiging 1 megabyte. Pag i-double natin yung bus. Okay? Pag i-double natin yung speed, magiging 4 megahertz siya, di ba? Instead of 2 megahertz. So from 4 megahertz, it will become 4 million bits. Okay? Ito times 2. Dapat, di ba dapat divided by 2? Divided by 2 pala, no? Kaya pala mali yung ating ano. Times 8 divided by 2. Mali ito. Equals this times 8. 8 kasi divided by 8. Dapat ba divided by 8? Divided by 8, mali. I'm sorry, no? Kasi 8 bits man per second. Tama, divided by 8. Okay, tama. So this is equals, kopyahan ko na lang to. Kopyahan ko na lang ni. Divided by 8. Mali yung aking calculations, no? Ayan. So pila ang naitabo karon? 1 MB lang yapon. Mali yung calculation ko kanina, no? Kasi dapat ito divided by 8 because there are 8 bits. Times 2 because 16 bits man. Di ba? Do you follow? So sa original, 500k bytes per second. When we double the bus, we have 1 MB per second. When we double the clock, we still also have 1 MB per second. So what does it mean? Pareho lang sila, but it doesn't mean they're the same. Why? Because when you double the bus, imagine the circuitry that is involved in the bus. No, you are going to add 16 more wires. And then remember, you have a very small space on a computer motherboard. Lalagyan mo yun ng 16 more wires to connect, no? The registers together. That will be a very complicated design process because you are going to connect 16 more wires. Ito, you're not going to change any circuitry. You're not going to change the motherboard. Do you follow? Ay, babaguhin ba tayo dito sa motherboard? Wala tayong babaguhin sa motherboard. Kaya lang, the clock is very expensive. You will need a very expensive, no? Wiring the clock, no? Kasi dapat yung wires na gagamitin mo should also be very expensive. Kasi mabilis eh, no? Diba? Mas malalaking wires. Kung sa kuryente pa, mas dako siya ka amperage. Do you follow? Do you follow? Do you get my point? Did you get this? Kuha niyo itong answer nito. Did
Yes,
anyone
sir.
get? Ha?
Yes, sir.
1 MB ang gawas?
Ang explanation ko, sir, kay more on bottlenecks po, sir.
Oo. Pero
Bottlenecks.
the bottom line is, how much is the data transfer rate? Ano lang
Yes,
talaga
sir.
yung, di ba? Kung magkano yung ma-transfer niya every second. Okay? Di follow? So, memory map IO, no? Port address IO. Yung example na ito is port address ito. The disadvantage with port address is you will have separate instructions. So, meron kang load memory, meron ka ring load IO. Meron kang store memory, meron ka ring store IO. So, you will have a complicated instruction set, which means that it will be more difficult to program. No? However, no? There will be the problem with memory map IO is, of course, you will use a certain part in memory na hindi mo na magagamit. Instead na magagamit mo sana, hindi mo na magagamit kasi nakamap na yon, naka-reserve na, may nakaupo na doon, no? Na mga VIP, they are port devices. And the problem with memory map IO is synchronizing between different speeds of IO kasi yung memory mabilis and then it has a uniform speed. But the different IOs have different varying speeds. Iba yung speed ng printer, iba yung speed ng hard disk. So, there's a circuitry that is used to synchronize memory map IO. Do you follow? Sa port address IO, wala nang circuitry to synchronize between memory and port because it's a different circuit. However, the problem is you will have extra instructions. So, mas lisod po siya i-program. The more instructions, the harder it is to program. Okay? So I'll upload this. Okay? I'll upload this to our, so you can have, so pareho-pareho lang yung ibang questions today. No? It's just common sense questions which you need to really, I will stamp your, i-check ko na yung, next meeting, no? Sana tayo, sandali lang tayo sa bus architecture kasi obsolete naman yung iba, mag-PCI lang tayo. We'll just discuss PCI and PCIe. PCIe and PCI Express, no? Do you follow? And then we go to memory organization. And then I think that will be our final topic, no? Okay. So ilalagay ko, no? Ano nangyari? Add files ito, upload. I-upload ko na yun. I-download ko niya. Mali yata na. Mali yata. Sorry na. Bakit hindi siya mag-upload ng file? Drag and drop the files to add. Really? Bakit hindi siya mag-add ngayon? Ayun na. Okay. Okay. Nandun na, no? Okay. So it's here, no? Any questions so far? It's almost 3 o'clock. So see you next meeting, okay? Thanks for coming. Did I miss anyone?
Yes.
Did I miss anyone in the attendance? I-check ko lang. Isa may absent, si Kona may absent. Si De Jesus, is De Jesus here?
Absent, sir.
Si De Jesus na may absent.
Yes,
Ah,
sir.
okay. So see you next meeting. I'll upload the lecture now. Thanks for coming, everyone.
Yes,
Yes,
sir.
sir.
Bye,
Yes,
sir.
sir.
Bye.
Bye, sir.
Bye, sir.